Inverse function. The function f of x must give exactly one unique output for each input. Okay? So each input has an output. Okay? A function that reverses or undoes the result of f of x is called an inverse function, and is denoted by inverse x. For an inverse function, f of minus 1, if you put an output into a function, you get an answer. Okay? And then when you put this answer into a new function, you get your original output back out again. So look, this is really confusing unless you put it into the context of a question. So look, what I'm going to do is just put it in the context of a question before I do anything else. Okay? This one here. Now there's 3 steps that you follow, okay? The 3 steps are in this blue box, and they're the steps that are always going to allow you to do any of these questions. Okay? So step 1 is let f of x be equal to y. Instead of using f of x, use y. Y equals 3x minus 2. Okay? The next step is we want to find the inverse function. What you do is you get x on its own. So what we first do is bring the 2 over to your side, and we get y plus 2 equals 3x. Then we divide x by 3. Or sorry, we divide y plus 2 by 3. Once you do this stage, express x in terms of y on its own. Done. Rewrite as f of x, f inverse x, replacing y with x. Replace x. X turns into, I'll just write it this way first. What happens is, x turns into, can anybody tell me? X turns into f inverse x. Y turns back into x. Now let me show you the context of this. Context of this would be the following. If I said f of 3. F of 3 is what, guys? F of 3 is 3 times 3 minus 2, which is 7. If I put 7 into this, f inverse 7, what does it do? 7 plus 2 over 3? 9 over 3 sends it back to 3. So, in a nutshell, the input goes into f of x and it creates an output. If I put this output through f inverse x, it brings it back to the original input. Do you want me to do another one? I'll do another one. Okay. Pick another number. Something easy like 5. F of 5, guys. Input is 5, okay? 3 times 5 minus 2 is what? What? 13. Now, replace 13 as your f inverse x, your inverse function input. So the output of our f of x is going to be the input for the inverse. And look what happens when we put in 13. We're going to get 13 plus 2 over 3. That gives us back our original 5. It's a way of going in reverse and finding out. Now, yeah. Lads, so look, what you're also going to see here is there's something that's very interesting about these functions, okay? So, sorry, I rubbed it out there. Now, this is the inverse function, yeah? And here is the original function. Now, what will always happen is this, okay? So, f of x was 3x minus 2. Now, here's what's always going to happen. Will somebody remember off these two for me? Just, you can write them down, that'd be perfect, alright? Now look what happens when you go into drawing these, okay? So, there's a line what's called y equals x. Does anybody know the line y equals x? What does it represent? It represents a 45-degree line. The y value equals the x value. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, minus 1, minus 1, minus 2, minus 2. Yeah? Now, if I draw these two functions, so for example, y equals 3x minus 2, okay, and I'll colour this in properties, I'll colour this in green, okay? Green is the original function. Now what's the value for the new function? x plus 2 over 3. Y equals bracket x plus 2 divided by 3. What do you think is happening there? Let me tell you what's happening. I'll colour this one in red. Okay? What do you think is happening? They're mirror images of each other in the black line. Look, same distance out every time. Do you see it? So this one has to point too far. Well, this one has to point 4, 2. Look, 2, 4, 4, 2. Take another one. 7, 3. What do you think this one will have? 3, 7. So, in effect, the blue and the red lines are interchanging x and y values. And that's why they're mirror images of each other in this line here. They're interchanging x and y values all the way along. Look at this one. -2, 0. What will be on the inverse function? 0 minus 2. That happens every time. Okay, without fail. So, I'll do a question on number 1 for instance, okay? Now, look at this one here. We'll try this one here. F of x equals 3 minus 5x, okay? F of x equals 3 minus 5x. Let's get the inverse function. Step 1, y equals 3 minus 5x. Step 2, get x on its own. You're going to bring 5x over here and y over here. 5x equals 3 minus y. Next step, get x on its own. X equals 3 minus y over 5. Next step after that, replace x with what? F inverse, replace y with x. Now, can somebody remember off or draw out for, just take this down, blue box and red box please. Blue box and red box please. Anybody have it yet? Okay, now look what happens when we draw these out. Okay, once again, draw the line y equals x. Now, what about the new function? What's the original function, sorry?
3 minus 5x.
3 minus 5x. It's a line exactly like you'd expect. Once again, we're going to let a green line represent the original function. So there we are there. Green line represents the original function. What's the new function?
3 minus x all over 5.
Now, you guys understand, you guys can do a rough sketch just using your calculator function, right? Now, look at this. And this one, the new one is going to be red. Okay? Now, pick any point. 0, 3 is on the original function. What's guaranteed to be on the new function? 3, 0. You get the gist, yeah? Okay. Now, let's try something with a bit more character. Okay, let's try number 9. Okay, now in number 9, what happens is g of x equals 3x bracket 2x minus 1. Okay, y equals 3x minus 2x minus 1. Now what you guys got to do is you got to isolate x. Now it's really difficult to do. First thing to do is bring this up and don't multiply it out. Okay, multiply it out. You get 2xy minus y equals 3x. Anything with an x goes on the same sides. 3x goes here, y goes here. We have 2xy minus 3x equals y. How do I isolate x? Can anyone tell me? Factorize. And then after factorizing, what can I do now?
Bring it over.
Bring it underneath. Now, what's my last step? Inverse x. Yeah. Oh, sorry. F inverse equals x over 2x minus 3. Now, let's examine the properties we were told. We know that if we were to draw this out, it'd be a mirror image again. We know this already. But let's look at what other things the language was telling us, okay? We now understand that basically your input goes into your original function. Your output from this function, if it goes back into the inverse function, it gives you back the original input. So if you put x in, you get an output. You put this output back into your original one, you get x back at the end of it. Yeah? Remember, I put in the number 3. I got the output, then I put the output into the new function, and I got number 3 back. Right? That's what that's explaining. A function that is not one-to-one, not injective, such as f of x equals x squared, can be arranged to be a one-to-one by restriction. So guys, because quadratic diagrams, okay? Because quadratic diagrams, you know when you get the outputs, yeah? Do you know why an output can give you two different inputs? What we do is we impose a restriction, and the restriction makes sure it behaves like an injective function, so that each output only has one input. So when we do the inverse function, we get the number we started off with. Alright, that's also important. Okay, we already know that when we draw it out, the x and y values interchange. We understand that, we know that. Okay, so that's what all the fancy language is about. Now, there is back to question 2 for 1 second, alright? If I was asked to prove that one function is the inverse of the other function, basically, how would you go about doing this, okay? So, this question here means, if I do f after f of x, so if I do f inverse of whatever f of x is, so if I do f inverse of 3x minus 2, what should happen is, I should get back out x. It should always turn out back to be x. So if I do f inverse 3x minus 2. What does that mean? Whatever is in the box is now 3x minus 2. So it's going to be 3x minus 2 plus 2 all over 3. And we're going to get 3x over 3, which is x. That worked, didn't it? Let's try the opposite way around. Let's try doing f of the f inverse, okay? So f of the f inverse. F of the f inverse means f of what? X plus 2 all over. And whatever is in here now replaces the x. 3 times x plus 2 all over 3 minus 2. 3 cancels with 3. X plus 2 minus 2? X. Once again, proves that the functions are inverses of each other. Okay, so let's go to this one here. Are these functions inverses? Justify our answer. How do we do this? If I do f of g of x, what are we expecting the answer to be? X. If I do g of f of x, what's our answer expected to be? X. Let's find out. Okay, and justifying our answer basically means we do this. So, f, it's going to be 1 over what? It's going to be f of 1 plus 2x over x. Anywhere I see x, I replace it with what's here. 1 plus 2x all over x minus 2. Let's find out. So it's going to be 1, and I should make this an x and this one an x here. So I'm going to end up with 1 over 1 over x, because the 2x is cancelled. And then I'm going to bring that up, turn it upside down to x over 1. And then what's going to happen then? The answer is x. It proves that it's an inverse. Do the other way around. G of f of x. So that means it's going to be g of 1 over x minus 2, which means replace this box here and this box here with 1 over x minus 2. So it's going to be 1 plus 2 over 1 minus x minus 2, all divided by 1 over x minus 2. Now, I'm going to change the number 1 into what, guys? Go and change it into x minus 2 over x minus 2. So they all have the same denominator. Now look at this. It's going to be x minus 2 plus 2 all over x minus 2. And on the bottom, I'm going to bring the bottom to the top, turn it upside down, and I'm going to get x minus 2 over 1. Cancel and cancel, cancel and cancel. Answer is x. No bother. Right, moving on. Number 8. A function f is defined by f of x equals 2x plus 1 over x plus 2, where x is an element of R and x has to be greater than minus 2. Find the coordinates of the points of intersection of y equals f of x and y equals inverse x. Okay, let's find this out. Okay guys, replace f of x with what? Replace with what? We're trying to find the inverse function. Y. Okay? Y equals 2x plus 1 all over x plus 2. What do we do next? Cross multiply to get x on its own. Yx plus 2y equals 2x plus 1. What's the next step? X is to one side, y is to the other. Yx minus 2x equals 1 minus 2y. Finally, x bracket y minus 2 equals 1 minus 2y. X equals 1 minus 2y all over y minus 2. What's our last step? Our last step is replacing. Sorry? Replacing x with f inverse x and replacing y with x. This is our inverse function. Now, will somebody be so kind as to write that function down for a minute? Okay, and once you have that function taken down, you're just going to call me out the two functions, okay? Now, what we're going to do here is just going to probably undo it, probably the quickest way of doing this. What's the control Z, is it? Control Z, control Z, control Z. Okay, cool. What's my two graphs, guys? What's the first one? Y equals
2x plus 1 over x.
2x plus 1 over
X plus 2.
divided by x plus 2. Now guys, this is a very difficult function to draw. You won't necessarily be drawing it, okay? But I just want to give you some context to the question we're doing. So this one here is in, we'll go for pink there, okay? Now guys, that's in pink. The original function is in pink. What's the next function? Y equals
1 minus 2x.
1 minus 2x over?
X minus 2.
Over x minus 2. Now guys, look at this. There's the other one. And I need to colour this in probably green, okay? Green is the inverse function. Pink is the original function. We can see quite clearly that they are mirror images of each other. We can also see quite clearly that there are two intersection points. Now, what most of you guys are telling me is, look, the answer is minus 1, and 1, 1. What you guys are telling me is, like, I can't draw that out in the test. How do I do it without having to draw it out? Well, the answer is algebra. This here represents the y value of the inverse function. This one here represents the y value of the original function. When functions intersect, their y values are identical. This means that if I get the y values using these two formulas, it means that these two formulas must be equal to each other when the curves intersect. We're going to cross multiply, we're going to get a quadratic equation now. So we're going to just multiply this out in one go. I'm going to get 2x squared. I'm multiplying this one by this one. 2x squared minus 4x plus x minus 2. Okay, and I'm obviously running a bit out of space here, so I just want to drag it down. Okay, so 2x squared minus 4x plus x minus 2. And then I'm going to multiply this one here by this one here. and what I should get is x plus 2, and then, so x plus 2 by 1, and then I'm going to do minus 2x squared minus 4x. Okay, just do it a slightly different way. Now, look what happens here. Minus 4x cancels with minus 4x, and then I'm going to bring over the 2x squared, and I'm going to get 4x squared. Do the x's cancel?
Yeah.
Oh yes, the x's will cancel. Bring over 2 over the other side, and we get minus 4. That's minus 4. Take out 4, divide both sides by 4, and we get x squared minus 1 equals 0. And then we can do it two ways. We can say x plus 1, x minus 1 equals 0. And that will mean x equals minus 1 and x equals 1. Now, it wants the points of intersection. That means I also have to calculate the y value. So y equals 2x plus 1 all over x plus 2. And what I can do is just replace in x twice. So I can say here is y equals 2 times 1 plus 1 all over 1 plus 2. And that's going to be 3 over 3, which is 1. Replace that with a minus 1 now. And what will turn into is minus 1 over 1, which means y equals minus 1. The 2 points are minus 1, and 1, 1, as depicted on our diagram here. Okay? Now, moving on. Number 10. Okay. Functions f and g are defined by the formula f of x and g of x. Find f after g of x, guys. Now what is f after g of x? Can anybody remember? It basically means f of g of x. Okay? This means replace whatever is in the box with whatever is now there. It's going to be 3 times x plus 5 plus 1, which is going to be 3x plus 16. Now that you've got this 3x plus 16, what do you have to do with it now? You have to inverse it. So we're going to say y equals 3x plus 16. We're going to inverse this. So we're going to get 3x equals 16 minus y. X equals 16 minus y all over 3. So the answer to this first question is 16 minus y all over, 16 minus, technically it's 16 minus x now, isn't it? Because you replace y with x. That's your answer to the first one. Now, what I want you to do is verify. What does verify mean language-wise?
Proof.
It is. It's going to be equal. If it isn't equal, you've gone wrong. Now, what it wants me to do is find out what f inverse is. So how do I find out what f inverse is? F inverse is going to be 3x equals 1 minus y. X equals 1 minus y over 3. F inverse x therefore is 1 minus x all over 3. Now I have to find out what g inverse is. What's g inverse? Y equals x plus 5. X therefore equals y minus 5. G inverse x therefore is x minus 5. Now that I've done this here, I now have my two functions that I need. Get this information, bring it over to the right.
So what's the 1 5? It's not plus 5.
It was plus 5. I inversed it already. So Connor, what I did was I said y equals x plus 5. I brought 5 over the other side. Y minus 5 equals x. And then I changed x into g inverse x. Thank you. G inverse x, and I changed y into g inverse x, and I changed y into x and x into g inverse x. Okay, like I did in the original question. Now that I've done this, guys, what it wants me to do is find out what is g inverse f of x. So it basically wants me to get the g inverse of 1 minus x over 3. Yeah? And what is G inverse x again? G inverse is whatever is in the box and then take away 5. So this G inverse 1 minus x over 3 is basically 1 minus x over 3 take away 5. Now, take away 5, is it?
It's meant to be negative 2.
Sorry?
It's not meant to be negative 2 for this full bracket.
My error was found to be in the original question, not the part B. Okay? So the original question is where I found my error. Is where my error is. So I'm going to have to do this again, okay? So I have to do f of g of x again, okay? So it's going to be f of x plus 5 equals 3 times x plus 5 plus 1. That is 3x plus 16 equals what, y. Then I've got to find out what y is. So it's going to be y minus 16 equals 3x. X equals y minus 16 over 3. F inverse x equals x minus 16 over 3. That's what I'm looking to prove it's equal to. So now that I have that done, I made a mistake in the original part. That's what I'm looking to prove it's equal to. And now look at this. Common denominator is going to be 1 minus x over 3. Now, 1 minus x over 3. So, now that that's x minus 16 over 3, what I should do is I should probably recheck G inverse and F inverse. So, I know. This one here is y equals 3x plus 1. Just trying to find out what F inverse is. F inverse is you're basically taking the 1 over the other side, so 3x equals y minus 1, x equals y minus 1 over 3. This means that F inverse x equals x minus 1 all over 3. So that's where another mistake was made there, but that's x minus 1 over 3, which means that I changed this around here to x minus 1 over 3. So that there should be x minus 1 over 3, which means that this part here is also x minus 1 over 3 minus 5. And then finally, what's going to happen is we're going to get x minus 1 over 3 minus 15 over 3, which is x minus 16 all over 3. And that's the inverse function. They are equal. So that one there must equal this one here. It is verified. Okay, number 12. Find the inverse function. When you find the inverse function, verify that when your input is 3, your output is 4. That's what this is basically saying. Okay, so I'm going to find the inverse function. Y equals 2x plus 1 all over k minus x. Then we're going to get yk minus xy equals 2x plus 1. Bring everything that has x onto one side. So I'm going to do ky minus 1 equals 2x plus xy. Then we're going to factorize out, spin this around so that the x's are on the right hand side. And then once we do that, factorize out x, and what we should get is x into 2 plus y equals ky minus 1, Connor. Okay, x equals ky minus 1 all over 2 plus y. Replace x with f inverse x and replace y with x, and here is our function. Now what do we know about this function? When the input is 3, the output must be 4. When x equals 3, f inverse x must be 4. So 4 equals 3k minus 1 all over 2 plus 3. What's 2 plus 3? 5. Okay, so cross multiply. 20 equals 3k minus 1. 3k therefore is 21. K equals 7. Please remember, that in an inverse function, what is x becomes y, and what is y becomes x. Now, what I also want you to learn is this, guys, okay? What is f of 2.5? What is the function when the x value is 2.5? 2.5 is here, and the answer will be 3.5. Now you know that f of 2.5 represents 3.5. Now what's f of 3.5 then? 4. Okay, solve f of x equals x. When is the y value equal to the x value? What point?
0, 0.
0, 0. Actually, yeah. Another one? 2, 2, 2. X equals 2 or x equals 0. Find f inverse of 0.5. Okay? This means find out what happens when the y value is 0.5. Because remember, f inverse is the reverse of the function. It's meant to be x equals 0.5, yeah? It would normally be x equals 0.5, but because it's f inverse, it represents y equals 0.5, because the y and the x values interchange when you do an inverse function. So it's going to be, the answer to this one is 1.5. Now this one's difficult, okay? Explain why f 3 times doing f of 2.5 is not defined. Well, when we do it once, what's the answer? 3.5. That's f1. When we do it twice,
4.
f of 3.5 is 4. And when we do it a third time, we're basically getting f of 4. And f of 4 hasn't got a value. It's not divided. Yeah, but it's explained that f of 4 is too big. You can't find what it is. So the graph doesn't go that far. Okay? Now, this is the last type of question we're doing today. What they're called is, by completing the square, find the inverse of the following functions. Okay? What's very important is this part here at the end. What we do is, we complete the square. We take the first part here. Now what did I say you always do? You look at the x, that means x. You look at the minus, that means a minus. You half the number that comes in front of x. What is the number that comes in front of x? Half of it? Minus 3. Square that out and you get x squared minus 6x plus 9. We don't want 9, we want 1. What do we need to balance that out? Minus 8. And that brings it to x minus 3 squared minus 8. Now guys, we now have to find out what the inverse is, which means what? We got to isolate x. To isolate x, bring 8 over, and you get y plus 8 equals x minus 3 squared. Don't square it out, instead square root both sides. Square root of y plus 8 therefore equals x minus 3. We square root at both sides. You got to also remember, when you have x squared equals 4, the answer for x is plus or minus 2, or plus or minus the square root of 4. This means we need to have a plus or minus here. Finally, get x on its own, and what we're going to get is x equals 3 plus or minus the square root of y plus 8. Last step, replace x with x inverse, and we get 3 plus or minus x plus 8. Now, the problem here is it was a quadratic function to begin with. Yeah? And this means that outputs and inputs can't necessarily interchange. Why can't they interchange? Because an output will have 2 different inputs. It means it's not a straightforward interchange. However, if you strike off half the graph, then it is a straightforward interchange. Now, it states specifically that x has to be bigger than 3. If this is negative, it will make x smaller than 3. So what we need to do is we only accept the plus value. Okay? because the plus value will give you a value bigger than 3. Okay, let's try another one. Same steps as last time. Okay, so what we're doing here is number 16 part 4. Oh sorry, 16 part 3. Excuse me, 16 part 3 is with that one earlier. 16 part 3. h of x equals 4 plus 2x minus x squared. The problem with this one is the minus x squared. What you do when you get a minus x squared is you put a minus on the outside, or a minus 1, and you say it's going to be x squared minus 2x. Have I changed the question? Did I change the question? No, I haven't changed the question. Next thing after that, what I'm going to do next is I'm going to do what I did last time. I'm going to half the middle value and put it into brackets. And what happens when I half the middle value and put it into brackets? X minus 1 squared, and that's x squared minus 2x plus 1. This function now becomes 4 minus x minus 1 squared. Now what happens when I put that in there? In effect, I'm adding on, I'm taking away another 1, haven't I? So this here should be 5. Let's see if it works. 5 minus x squared minus 2x plus 1. Multiply in by the minus, and that will become minus, so it's going to become 4 minus 4 plus 2x minus x squared. It does work out. So let's go back to the manipulated part, which is here. Now we have h of x. We're looking to find out what h inverse is. What's the first step? Putting down y. What's the next step after that? Getting x by itself. I'm going to bring the square root part all over on its own. So why did I do that? Get the positive. Okay. Once that's done, what I'm going to do now? Square root both sides. And I'm going to get x minus 1 equals plus or minus the square root of 5 minus y. Upon completion of that, I'm then going to bring over the 1. X equals 1 plus or minus the square root of 5 minus y. Is there any restrictions on this? What's the restriction in the question? It can't equal? Oh no, it has to be bigger than 1 now. It has to be greater than or equal to 1. And if x is greater than or equal to 1, what does that mean? It can't be minus. Okay. Okay, this one, we're done. Okay, f of x, like last time, is going to be, I'm just going to plow through this one. It's going to be x minus 2 squared. The extra square adds on a 4. I want a 3, so you have a minus 1 at the end. I'm then going to change that into y. Upon changing that into y, I'm then going to bring it over, and I'm going to get 1 plus y equals x minus 2 squared. Going to square root both sides. Square root of 1 plus y, or plus or minus square root of y, equals x minus 2. Going to bring that over to your side, and I'm going to say x equals 2 plus or minus square root of 1 plus y. It's called f of x, therefore I must call this f inverse x, and that's 2 plus or minus the square root of 1 plus x. That is the answer to the first part. Okay, find f inverse x and state its domain and its range. Okay, what happens is... Okay, now lads, what happens is when you draw a function, okay, the x and y values, they both have to be real numbers. So do you understand? They both have to be real numbers. Now, the problem with a square root sign is, what's the problem with a square root sign? It can never be negative. You can never have the square root of a negative number. This means that x plus 1 always has to be greater than or equal to 0. This means that x has to be greater than or equal to minus 1. Is everybody happy with that? Now, The next thing is, did they put a restriction on it? They said x has to be greater than or equal to 2. This means that I don't have to worry about the negative part, I only have to worry about the positive part. And lads, what they're saying next is this, okay? What they're saying to do is, what they're saying to do is x has to be greater than or equal to -1, yeah? So what's the smallest value of y you're allowed? The smallest value of y you're allowed is when x is -1. When x is -1, the square root is 0. So the smallest value of y you're allowed to have is 2. It's going to be 2 or above. Now, if you were to put this into your table, alright, your calculator, and what you said is this. You said 2 plus the square root of 1 plus x. Now what you're saying is, it has to, if I started at 0, and let's say ended at 10, or 11 even, step of 1. When you draw this graph out, okay, oh, sorry, I had to start it lower than that. Lads, so when you start this, look at this. When you start at -3, you get an error. Why do you get an error? Because the square root sign is negative. It's negative. -1 is the first value in which it's 0. The value of the function is 2. And then you have 0, 3. And then your function is growing. So if we were to draw out this function, will somebody remember this formula for me, please? If you draw out this function, what do you get? It's going to be, what's a y equals? 2 plus square root of, sorry? 1. 1 plus x. Okay. There guys. Now, Simon, very similar to the one we had earlier, where it no longer exists. It can't cross this point here, okay? Now, what we're then asked to do then is we're then asked to draw the function of x. Lads, can somebody draw the function of x for me? X squared minus 4x plus 3. So y equals x squared minus 4x plus 3. You do that on your calculator, and there's your answer. On the same scale and axis, there's both your functions.